Have you ever wondered how some people solve math problems so quickly? The secret isn't just practice, it's knowing the right techniques. In this video, we'll uncover 4 powerful math laws that can simplify problems and save you time. Whether you're adding, multiplying, or breaking down complex equations, these laws can help you think smarter, not harder. By the end of this video, you'll not only know these laws, but also see how they make tricky problems easier. So grab a pencil, and let's get started with the 4 math laws you'll want to master. The first law we are going to explore is the law of identity. The law of identity for addition states n plus 0 equals n, or any number plus 0 equals itself. The law of identity for multiplication states n times 1 equals n, or any number times 1 equals itself. You probably already know that these are true. For example, if you have 5 apples and you get 0 more apples, you still have 5 apples. This is the law of identity for addition in action. Now let's look at multiplication. Imagine you have one box that contains 12 pencils. Since there is only one box, the total number of pencils is the same as the number inside that single box, 12 pencils. This demonstrates the law of identity for multiplication. Multiplying any number by 1 keeps it the same. Our next law is called the commutative law, which is also sometimes called the commutative property. The commutative law for addition states a plus b equals b plus a. And similarly, the commutative law for multiplication states a times b equals b times a. Note, this law does not work for subtraction or division. Let's try this out with some examples. Let's substitute a and b with some numbers. Let's use 6 and 3. Now, if we use the commutative law for addition, we get 6 plus 3 equals 3 plus 6. And if we solve this, we find that 6 plus 3 equals 9, and 3 plus 6 also equals 9. So these two expressions are equal, just like what we are told by the commutative law. Now let's test the commutative law for multiplication. 6 times 3 equals 3 times 6. And if we solve for this, 6 times 3 equals 18, and 3 times 6 also equals 18. Awesome. Now let's see why the commutative law does not apply to subtraction or division. If we try making a commutative formula for subtraction, we get 6 minus 3 equals 3 minus 6. But if we solve these expressions, we find that 6 minus 3 equals 3, while 3 minus 6 equals negative 3. These results are different, so the law does not work for subtraction. And similarly, if we tried using the commutative law for division, 6 divided by 3 equals 2, but 3 divided by 6 equals 1/2. Different results again. So remember, the commutative law is just for addition and multiplication. Our third law is the associative law. The associative law for addition states a plus b in parentheses plus c equals a plus b plus c in parentheses. And the associative law for multiplication states a times b in parentheses times c equals a times b times c in parentheses. And just like the commutative law, there is no associative law for subtraction or division. Now, all these symbols may look very confusing, so let's see it in action. Let's replace a with 1, b with 2, and c with 3, just for simplicity. Now let's evaluate. Here, we have to use the order of operations. If you're not familiar with the order of operations, you can check out this video right here. Now, remember, the first step in the order of operations, PEMDAS, is parentheses. So let's tackle those first. The first parentheses is 1 plus 2, which is 3. So we simplify to 3 plus 3 equals 1 plus 2 plus 3 in parentheses. The other parentheses is 2 plus 3, which simplifies to 5. So now we're left with 3 plus 3 equals 1 plus 5. And that's correct. 3 plus 3 is 6, and 1 plus 5 is 6 as well. Now let's try the associative law for multiplication. Let's use different values for a, b, and c. Let's use 2 for a, 5 for b, and 10 for c. Okay, so to start, we need to do the parentheses first according to the order of operations. 2 times 5 is 10. And the other set of parentheses is 5 times 10, which is 50. And now we have 10 times 10 equals 2 times 50, which is correct, because 10 times 10 is 100, and 2 times 50 is also 100. Great, it worked. Can you see the associative law being used in a practical equation? Let's say we have an expression we need to simplify. 21 times 25, in parentheses, times 4. Now, in this expression, it may be difficult to find 21 times 25 since it's double-digit multiplication. But using the associative law, what is another way we can write this expression? Well, if we move the parentheses over, we get 21 times 25 times 4 in parentheses. And look at that. What is 25 times 4? It's 100. So now we have 21 times 100, which we can easily simplify to 2,100. If we try it the other way, 21 times 25 does come to 525, and once we multiply that by 4, we also get 2,100. But one method required much less effort than the other. If you can memorize these laws and get familiar with them, you will be able to find quick and useful shortcuts to solve big problems. Our last law is the distributive law. The distributive law states that A times B plus C in parentheses equals A times B plus A times C. Let's jump straight into an example and see the distributive law in action. So let's let A equal 2, B equal 4, and C equal 6. The first thing we need to solve is the parentheses. 4 plus 6 is 10. So let's put that in. Now, according to the order of operations, the next step is to evaluate multiplication. 2 times 10 is 20, 2 times 4 is 8, and 2 times 6 is 12. So now we are left with 20 equals 8 plus 12. And knowing that 8 plus 12 is indeed 20, this equation is true. The distributive property is a powerful tool that can simplify solving equations and expressions. Let's take the example of 16 times 25 plus 16 times 75. Now, these are large numbers, and instead of jumping straight into the calculations, we can apply the distributive law. Notice that this expression resembles the second part of the distributive law. That means we can rewrite it as 16 times 25 plus 75 in parentheses. These two expressions mean exactly the same thing, as we are told by the distributive property. Now, according to the order of operations, we should first handle the parentheses. So, adding 25 and 75, we get 100, and we're left with 16 times 100, which we can easily simplify to 1600. By using the distributive law, we avoided some double-digit multiplication and saved a lot of time. Now, let's try some hands-on practice with these math laws. Take a look at this expression. What law can we use to make solving this easier? Take a moment to think about it. If you thought of the associative property, you're correct. The associative property lets us change the grouping of numbers when adding or multiplying. Using this property, we can rewrite the expression as 17 plus 13 in parentheses plus 70. Now let's solve it step by step. First, we add 17 and 13, which gives us 30. Then, we can add 30 and 70, and we get the final answer, 100. By applying the associative property, we made the calculation easier and arrived at the right answer. Okay, let's try another example. Here's a similar example. See if you can find the trick to solving this. Clue: if you do it right, you won't have to do a lot of work. At first, you might think the associative law for multiplication might help. But moving the parentheses gives us 25 times 128 in parentheses times 4, which is still tricky. But what if, to start, we use the commutative law of multiplication? If we swap places in the parentheses, we get this. Now, if we used the associative law now, we get this expression. And this is great. What is 25 times 4? It's 100. And 100 times 128 should be pretty straightforward. Just put 2 zeros at the end and we get 12,800. Awesome work. See how much work we saved because we knew our math laws? Let's try one last example. Now, using math laws, how can we solve this expression? I know it may look kind of hard, but give it a shot on your own. I'll give you a hint. We need more than one law. Now, pause and give it a go. Okay, so first off, does this look anything like what we already know? Well, we know that the distributive law's second half is AB plus AC. Now, if we try replacing numbers here with variables, we get AB plus BC. This is kind of close to that, isn't it? But what if instead of making 9B, we made it A and then we made the 24 the b. Well, then we get BA plus AC. Now the only difference here with the second half of the distributive law is that the AB and BA are switched around. But remember, the commutative law of multiplication states AB equals BA. So these are actually the same thing. Another way we could have written our expression is 9 times 24 plus 9 times 76. And according to the distributive law, we could write this as 9 times 24 plus 76 in parentheses. Now let's solve the parentheses. 24 plus 76, that's 100. And 9 times 100 is 900. And that's the answer to this problem. We did a little bit of thinking and avoided some hard multiplication and triple digit addition. This one may have taken a bit of thinking. But see how math laws really make life easier? That's why it's so important to know them in and out. So let's quickly recap. The law of identity for addition states a plus 0 equals a. The law of identity for multiplication states a times 1 equals a. The commutative law for addition states a plus b equals b plus a. The commutative law for multiplication states a times b equals b times a. The associative law for addition states a plus b in parentheses plus c equals a plus b plus c in parentheses. The associative law for multiplication states a times b in parentheses times c equals a times b times c in parentheses. The distributive law states that a times b plus c in parentheses equals a times b plus a times c. Look at these and remember these. I can promise that these will help in the future. Now, on your own, solve these 3 problems. I'll give you a clue. All 3 of these shouldn't be that hard if you use the correct laws. Comment your answers down below and check the description for the answers. You got this. If you enjoyed this video and want to see more like these, please consider liking and subscribe to the channel. If there are certain videos you want to see, let us know in the comments. If anything was confusing or you have any ideas where we can improve, drop it in the comments below. We'd love to help and we'd love to get better. That's it for this video. Now, keep working hard and keep learning. Thank you for watching.